So now we are in lesson 11.1. It's axiomatic probability system. We start first, the first part, it's set rules and theory. We are a little bit learning about the language of probability. Now, if I see A union B, this one we read it union. What does mean A union B? The definition is X, whether X belongs to A or X belongs to B. It means that A union B represent all the elements that are in A and B. So if I want to graph it or draw it, this is the Venn diagram that represents A union B. So when I say A enter B, it means it's the element that are in A and in B. It means it's the intersection. So what's in between A and B. Now, if A is included in B, so I have it here in this figure. If A is in B, what's going to be A enter B? What is the intersection? What is the common between A and B? It's A. What will going to be A union B? It's all the event B, because I need all the elements that are in A and in B in the same time, so it's B. Now, what is this notation here? This notation, we read it phi. Phi, it means it's empty. It's an empty event. What is A enter an empty event? It's going to be empty. What's A union phi? It's A. P of an empty event, the probability of an empty event is 0. The probability of UU, it means it's all the set. For example, let's say you represent the class of grade 12. Okay, what is the probability of choosing a student from the class? It's certainly 1, because in this class there is just students. So P of U is 1. But if I say, what is the probability to choose a cat from the class? There is no cat in the class. This is an empty event phi, so it's 0. All the time, the probability of any event is between 0 and 1. P of any event, the probability of any event, it's the favorable cases over the total. What does it mean? I'm going to give you an example. If I say, for example, in a class I have 12 girls and 30 boys. So it means in total I have 42 students. So if the question is, what is the probability of choosing one girl? So how many girls do we have here? We have 12 girls. So I can choose one of the out of the 12. I wrote here the Lebanese notation. Let me write. So I can write like this. It's C1 12 over C1 42. So it means I can choose one girl from 12 from the total. This is the favorable over the total. And then it's going to be the probability 2 over 7. Let's have more formulas. What is P of A union B? It's a formula. It's P of A plus P of B minus P of A enter B. Why did I subtract the intersection? Because when I'm counting A and B, I'm counting all A and all B. As I'm counting the intersection twice, because the intersection is in A and it's in B. So if I add just A and B, it means I'm adding twice the intersection. So I need to subtract one of the intersection. But if A and B are independent, what does mean independent? Also, we can use the term mutually exclusive. It means there is no intersection between A and B. In this case, the probability of A enter B is 0. So what's gonna be P of A union B? It's P of A plus P of B. Guys, what all I'm doing now, we're gonna do now an example after I finish those properties. You can see the notation A bar or A prime. A bar or A prime, it means the complementary of A. It means the opposite of A. So if A, for example, represents the number of girls in a class, what's going to be A prime? The number of boys in the class. And the probability of A prime is equal 1 minus P of A, because they are opposite events. So the probability is 1 minus the second probability. Let's now continue what you're doing by doing an example. I have the last property and then we're going to do an example. We have P of A enter B plus P of A enter B prime. It's P of A. This one now, I will see it later on in an exercise and you will understand this formula. Okay, let's do the example. There are 12 girls and 10 boys in a class. It means I have 22 students in total. 2 students are selected for the school government. So I need to choose. It's a choice. It means it's a combination. I want to choose 2 students. And how many different ways can 2 students be selected from the class? It means how many possibilities I have. So I'm choosing 2 out of 22. It's 231. Now, find the probability that the selected students are both girls. If I want to be sure that the two students are girls, I need to choose it from the girls. So I have 12 girls, so it's C2 12 over the total C2 22. So it's 66 over 231. If I want them to be both boys, it means I need to pick them from the 10 boys, so it's C2 10 over C2 22. And if I want to have one girl, one boy, so I'll take one girl from the girls, C112, and one boy from the boys over C222, and I will get the answer. It's very simple, guys. Now let's move to the conditional probability. It's very important, the conditional probability. Also, I will do an example to get it more. First, the notation, you write P of A slash B. And how do we read that? We read the probability of A, of the event A, knowing that B is occur. So when I see the word knowing that, it means this is the event here for knowing that. And in this case, there is a trick here, the total will change. What does it mean? Also, we will see it in the example. So the formula of, now sometimes you can solve an exercise using a formula, sometimes without the formula. But the formula of P of A slash B, it's P of A enter B over P of B. Also, if you cross multiply, you can have the formula of the intersection. It's P of A slash B times P of B. Now, if A and B are independent, it means there is no relation between A and B. So A can be occurred without B being occurred because they are not independent. So it's gonna be P of A slash B, it's P of A. So in this case, the probability of the intersection is P of A times P of B. Guys, when I say conditional probability, it means, let's say, knowing that the chosen student is a girl. So here I'm sure that I'm just working with the girls. I don't have any more. The total is not more 22. The total now is 12. So the denominator is going to be C2 12. I will continue the question. For example, what is the probability that she's wearing glasses? So I'll just choose from the girls that they are wearing glasses. So my numerator will be the number of girls that are wearing glasses. We will see it in another example. That's it. In a class, we have 20 girls and 10 boys. Out of the girls, 15 like to read, and out of the boys, 7 like to read. So I can do a tree diagram here. Those are the 30 students of my class. I have 20 girls and 10 boys. Out of the 20 girls, 15 likes to read, and out of it's 15, if 15 likes to read, it means the 5 doesn't like to read. The boys, 7 like to read, and 3 doesn't like to read. Now, one student is chosen. What is the probability that it's a girl and like to read? So when I say girl and like to read, it means it's intersection. Girl and like to read. It means I'm choosing a girl that likes to read. How many girls that is? 15 out of how many students out of 30? So it's C115 over C130. How I can think about it? Sorry, guys. How can I think about it differently? When it's not conditional probability, I'm standing here. What the question is? The question is I need a girl, so I'm moving this here. So from the 30, I'm going here. And then I want this girl to read, so I'm going here. So this is my road for the intersection. This is the road for P of G enter R. So I need to choose 30, 15 from 30. But if I say here, knowing that it's a girl, it means I'm 100% sure that it's a girl. It means I'm not anymore standing here. My total is not anymore 30. I'm now here. So my total is now 20. So now I am here. So here it's just the conditional probability. So knowing that it's a girl, what's the probability that she likes to read? So how many girls likes to read? It's C115. But out of the girls, so it's C120 because now I'm here. I took the girls apart and I'm choosing just from the girls. That's why I said here in the formula the total change. So the conditional probability, it means I skip a step and now I'm here. I know where am I and I'm choosing from the 20. So here I'm doing it without using the formula. Now let's do another example. Okay, if you can read here. Yeah. The probability that a train is late is 0.3. If the train is late, the probability that Florin will make it to work on time is 0.6. If the train is not late, the probability that Florin will B on time for work is 0.9. Now, let A be the event the train is late. So I'm going to repeat again. It means I'm starting from the train is late. So I will read again. The probability that a train is late is 0.3. It means the train is late 0.3. What is the opposite event? It's not late. So A prime, how are we going to find how it's 0.7? It's 1 minus 0.3 is 0.7. Now I'm here. They said no, the probability that Florin will make it to work on time is 0.6. So if the train is late, so I'm here. To be on time, it's 0.6. It means I'm not on time, it's 0.4. And then they said if the train is not late, so I'm standing here now, the probability that Florin will make it on time is 0.9. It means not on time is 0.9, sorry, it's 0.1. Draw a tree diagram to represent this event. I did it already. Find the probability that the train is late and Florin is not on time. It means A enter B. So it means A, this is my road, enter B. That's it. So it means it's 0.3 times 0.6. Now, this is the formula that I was talking about, and I told you we will see it. Find the probability that Florin will make it on time. Okay, it means it's P of B. She can make it on time, or she's late or she's not late. So, being on time, it could be being on time and late, so P of A enter B, or being on time and she's not late, P of B enter A prime, and then I will add. So I can be on time by following this road, or this road. It means it's 0.3 times 0.6 plus 0.7 times 0.9, 0.81. This is formula that I told you that we will see it later on. That's it. This is the formula that represent the exercise that I was doing now. Okay? Now I will move to the last property. It's Bayes theorem. So if A1, A2, A3, AN are infinite set of mutually exclusive events, it means independent events. It means that probability of the union is the probability of the sum. And also it means that A1, A2, A3 represent all the set. The probability of AI slash B, it's P of AI slash P, B slash AI over P of A1 times P of B times A1 plus. Okay, you're going to look at the formula and say, what is that? I didn't understand anything. Okay, I will explain the formula by doing an exercise. And this formula comes from the base formula of the condition probability, because we know that the condition probability, it's P of the intersection over P of B. But how this I got this formula, we will see it now in the exercise, and you will get it, guys. Just give me 1 minute. That's it. I will understand everything now. 3 students, Lauren, Maddie, and Georgie, work in a coffee shop. In any give hour, Lauren will make 55% of the coffee. So it means P of L. I wrote P of L for Lauren, 0.55. Maddie will make 45%. 45% means 0.45. And Georgie, 10% means 0.1. Now, the probability that Lauren, Maddie, and Georgie spill some coffee, it means knowing that Lauren did the coffee or knowing that Maddie did the coffee, the probability of spilling the coffee is 0.6, 0.2, 0.1. So it means I can write it P of S knowing that it's Lauren who spill it knowing that Maddie, spill it knowing that Georgie is 0.1. The question is, given that a coffee is spilled, when they say given that the coffee is spilled, it means it's a conditional probability. It means it's a slash G here. Sorry, S. Okay, that's it. Did you see it? This is given that the probability is spilled. Okay, find the probability that Maddie did it. Let's say I forgot Bayes theorem. Okay, just let's look back to the formula. The conditional probability gives me it's P of the intersection over P of S. Excellent. P of M enter S over P of S. Okay, how are you gonna find P of M enter S? I don't have it, it's not given. What's given, they gave me P of M and P of S enter M. But also I know that P of S, knowing that M is occurred, it's P of S enter M over P of M. If you're gonna cross multiply, you're gonna have P of S enter M, it's P of S slash M times P of M. This is what it's written here. Excellent. I'm done with the first part. Now I still have the probability of P of S. What does it mean? Splits the coffee. Spill the coffee. Who gonna spill the coffee? It's either Lauren, either Maddie, either Georgie. It means P of S is what? It's P of S enter L plus P of S enter M plus P of S enter G. Do I have those? Those also are not given. How are we gonna find those probability? Also, again, like I did it here, P of the intersection, if you cross multiply, it's P of the conditional times P of the M, like here. It's the same thing. So what gonna be P of S enter L? It's P of S times P of S slash L. Those are the same. If I replace it now, I can see here the Bayes theorem. I can see it. And then all what we need to do is to plug in the values and to get the answer. So even if I didn't get Bayes theorem, I can do it step by step and I will reach to the formula without knowing, guys. That's it for this video. Watch it again if you didn't get it, and you will do more application in the class.